Hello students. Next we are going to look into the transient analysis of RL networks. For studying the transient analysis of RL networks, what we have to understand it, what we are trying to do here is we are trying to obtain what are the currents and voltages, in any RL network. RL network means network which has a resistance and inductance, which has only resistance and inductance, no capacitance. So in an RL network, what are the currents and voltages and how they are going to behave when the circuit is going through a transient stage or transient state. Let me again explain what was transient state and the currents and voltages associated with it. See, initially the circuit is in an initial state, and then there is some switch somewhere. There is some switch which is either switched on or off. Based on that, a change is occurring and the circuit goes through a transient stage. And once it goes through a transient stage, it goes from a transient state to slowly a final state. And in the final state, it is again all the currents and voltages are reaching a saturation. So we'll try to understand this much better with the help of example. So what we are going to do here is we are going to take the case of step input, impulse input, and for the case of sinusoidal input. So we will start with the first one, which is a step input. So let me first draw the circuit diagram. So here we are having a circuit which is having a switch. A switch will go down, let us say at a time t is equal to 0. So before t is equal to 0, there is no voltage that is being applied. Okay, why? Because the switch is open and there is no energy or there is no current that is flowing through the circuit. So at t is equal to 0, if I would look this as the t axis and this is 0, then up till t is equal to 0 there is no value. Okay, as soon as t is equal to 0 is coming, the switch is turned on or the switch is put down, and suddenly the circuit is connected to a voltage which looks something like this. So up till here it was 0. As soon as it reaches 0, the switch is turned on and we are getting some voltage V. So what is this? This is basically a step, isn't it? This is a step signal. But here it is not unit step signal because it is having an amplitude of V. So we can very conveniently say that this can be written as V u of t, where V is the amplitude, whatever is the amplitude. Now for our sake, what we will do is, we will take this value of V as, let's say 5 volt. So here we are going to have 5 volt, so I will write this as 5, and here it is going to be 5 u of t. So again, this is a simple example that I have put. I could have basically taken this as R, this as L, and this as some voltage V, and I could have done the same equation, but generally as a derivation it is not asked. It's mostly asked as a problem, so as a numerical. So I will also try to solve this as a numerical. Okay, so suppose you are having this situation, there is an R and an L. The value of R is 4 ohms, the value of L is 2 henries, and there is a voltage V attached. And what we have to find out is, at t is equal to 0, when the switch is put, there is some current going to flow through this, and that current is going to be I of t. I want to plot the the waveform of I of t, or I want to find the mathematical expression of I of t so that I can plot it from t is equal to 0, what is going to be. So how do we do it? So let me rub this one. So this is something that we'll find at the end. So the first thing that we do is we first write what is the voltage that is going to come. So now I will write that the voltage applied to the network V of t, originally this should have been written as V of t. Now since this is a simple battery with 5 volt, I have not written this T, but I can write T because there is a switch associated with it. So you remember, whenever there is a battery and a switch coming together, it is not a simple battery, but it is a function V of t which is equal to 5 times U of t. Not 5 times, whatever is the value of battery. Okay, so that you must remember. So right now I will write it as V of t because we have to solve it. So it's a time based voltage which is 5 times U of t, and taking Laplace transform of V of t, we will get capital V of s. Whenever you take the Laplace, remember it is capital. So capital V of s is equal to 5 times, we know U of t is 1 by s, which makes us 5 times 5 by s, sorry. So that is the voltage that is going to be applied. Therefore now we have to convert this into a transformed circuit. So what is the transformed circuit? How do we write it? If you remember, we had studied in our previous class that whenever you are having a inductor like L, if there is an initial condition, then you will put it with, you will make a transformed circuit. The transformed circuit will basically have both Ls and the initial condition. If there is no initial condition, no need to write this voltage. Only L is getting changed to Ls, and that is what we have written here. L gets changed to Ls. Okay, so going by that, I can draw the transformed circuit as, so this is the transformed circuit. So this is the transformed circuit. So we have written, instead of V of t, it is now V 5 by S. So it is not V of t, it is V of S. And then we are having a current, we are having a resistance 4 ohms, that has not changed. The inductor has changed from L to Ls, so it becomes 2S. And now the current that will flow inside will not be I of t, but it will be capital I of S. And what my aim is to find out I of S. So see, what I am going to do here, I am going to go from I of t, I have taken the Laplace inverse, I have taken the Laplace transform, and I am going to get I of S. The circuit is transformed. Okay, then solve and find I of S. After I find I of S, what I do is, I will go from here and I will go back using inverse Laplace transform and get back my I of t. So I am, instead of coming like this and trying to solve this and getting I of t, I am instead using Laplace transform to solve it using, or in the S domain. Okay, so now since that is the case, so this is what we have done. Therefore, next what we do is, therefore I of S, finding I of S, therefore to find I of S, we take KVL. Of the loop. So when we are having current passing through this, this is plus, this is minus, this is plus, this is minus. So what we are having is, I will write V of S. So if I write from front of the element, then it is going to be 5 by S minus 4 I of S minus 2S I of S is equal to 0. From which I can very clearly say that I of S I can take commonly, and I will take the other side, then it will become I of S. From this I will get I of S 4 plus 2S 4 plus 2S is equal to 5 by S. Okay, how? I have taken these two values the other side. I have taken these two values the other side, and I have taken I of S common, and that's how I get it. So that part is done. So now I will get I of S as, therefore I of S is equal to 5 divided by 4 plus 2S, or let me write it 2S plus 4. That is the reason why I write it like that, I'll tell you. So I will write first 2S, whatever is the S component, and then plus 4 into what is already remaining there is S. Okay. Now this I can rewrite in a way, because I can rewrite in a different way, because I want the coefficient of S to be 1 always. So let me write here, note, always keep coefficient of S is equal to 1. So the coefficient of S should always be equal to 1. So for doing that, I have to divide by 2 here. So if I divide by 2, I have to divide in the numerator also by 2. So what I will do is, I will write it like 5 by 2 divided by 2S plus 4 divided by 2 into S. So what I have done, I have divided both the numerator and denominator by 2. So this will remain as 5 by 2, no issue. The denominator, this 2 and 2 and 4 and 2 will get cancelled. So I will get S plus 2. Okay, I will get S plus 2 into S. Now you can see the coefficient of S has become 1. So how did I do it? By dividing it by 2. Why did I divide it by 2? Because here the coefficient was 2. So this is the coefficient of S. The coefficient of S has been 2 here. So take out that 2. I will divide it by 2. So I have to divide in the numerator also by 2. That is what I have done here. See, there can be multiple equations like 5S plus 4 into 13S plus 6, something like this, that every time, so you have to divide this by 5, you have to divide this by 13. So in the numerator you divide by 5 into 13. Why? Because the denominator you have divided with 5 and 13. So like that, for any case, always you have to see that the coefficient of S is always coming equal to 1. So now using partial fraction, see, I have already found out I of S. Now I have to go back and take the inverse Laplace transform to get I of t. To get the inverse Laplace transform, I have to first do partial fraction, isn't it? So using partial fraction method, I can write I of S, which is 5 by 2 S into S plus 2 as sum A divided by S plus B divided by S plus 2. Now some of you may even ask me, so why are we writing A and B only? Why can't we write AS plus B divided by S? No, why can't we write it like that? And or even here, why can't we write it as BS plus C divided by S plus 2? Why can't we write that? See, here The denominator is a simple pole. Here also it is a simple pole. Unless we have what is called as a complex pole, we will never write it as Bs plus C. We will always write it as a single one. That we have already seen in the 4 cases of partial fraction. Let me again repeat, whatever you have to write on the numerator, that for understanding that you have to look into the the section of partial fraction, which we have already done previously. Okay, so now from here, therefore A, how do we find out A? How do we find out A? A is found out by multiplying with S, I of S. Why I took S? Because S is in the denominator. Okay, and equating it at S is equal to 0. Why S is equal to 0? Because here it's only S. If it is S plus 2, I will take S is equal to minus 2. I hope you remember partial fraction. Okay, based on that, I can find out A is equal to, so I will get 5 by 2 divided by S plus 2 at S is equal to 0. I will get the value as 5 by 2 by 2, which is 5 by 4. And similarly, B, I will get it by multiplying S plus 2 with I of S and putting the value of S is equal to minus 2. Based on that, I will get 5 by 2 divided by S at S is equal to minus 2, which will give me 5 by minus 4, which I will take minus on top. Therefore, I of S is going to be equal to, now look carefully here, I of S is going to be equal to A, which is 5 by 4 by S, plus B, which is minus of 5 by 4 by S plus 2. Therefore, taking the inverse Laplace transform, which I will write it as Laplace inverse of I of S, I will get 5 by 4 u of t minus 5 by 4 e raised to power minus 2t u of t. Let me write that, together. I can take u of t common and I can take 5 by 4 as common. So I can write this as 5 by 4 1 minus e raised to power minus 2t u of t. Okay, let me write that in the next page. So I have got I of t is equal to 5 by 4 times 1 minus e raised to power minus 2t u of t. This is what I have got. Okay, now I need to plot this. Now always in your examination, don't assume that you have to always plot it. There is no need for always plotting it. But here I will plot it because I want you to understand something. So if this is going to be taken as time t is equal to, not time t is equal to, it is t. Okay, so this is time t, and suppose this is I of t. We know that I of t is going to start only from t is equal to 0. So before that, the value of I of t was 0. Let me take another little bit more thicker pen. Okay, I of t was 0 before that. Now I am going to have, let me first draw what is the input. The input was u of t, 5 u of t. So let me draw that. 5 u of t, suppose this is 5. Suppose this is 5. So 5 u of t was this. This was the input. Okay, this was the input, 5 u of t. Now what is output? Output is this equation. The amplitude has become 5 by 4. So 5 by 4, let me draw it. is 1 by 4th of this, which let me, for the time being, let me show it like this. So this is 5 by 4 and this is 5. Okay, this one was 5 and this is 5 by 4. So how do you draw 1 minus e raised to power minus 2t? For drawing that, I will, let me put some value. This I will rub it off now. Tell me what is e raised to power minus 2t for different values of t. Okay, if t is equal to 0, this is going to be equal to 1. So I will write, this is okay. This is 1 minus e raised to power minus 2t, so which is our function, correct? So if e raised to power minus 2t at t is equal to 0, at t is equal to 0, e raised to power minus 0 or e raised to power 0 is 1, therefore this is 0. Then if I am going to take t is equal to 1, then you will get e raised to power minus 2, correct? You all try to find out using your calculator what is e raised to power minus. It comes out to be 0.14. So what is 1 minus 0.14? It is going to be 0.86. Next, if I am going to put t is equal to 2, what is going to be e raised to power minus 2t? T is 2, so this becomes e raised to power minus 4. So if you would use the calculator, you will find out that this value is going to be 0.018, which comes out to be 0.9, okay, 0.992, 982, okay, 981, sorry, this is going to be 0.981. Similarly, if I am going to take it as 3, then it is going to be e raised to power minus 2t, so t is equal to 3, therefore what will I get? I will get the value of e raised to power minus 6, which is again very, very small. It is 0.0024, which again gives me the answer as 0.99. So like that, if I am keeping on going, this will slowly approach 1. Okay, this will slowly approach 1. So what I can draw it is see, it is jumping straight away from 0 to a high value and then it is slowly saturating. So I can draw that as, let me use the big pen. So slowly saturating and then it remains at 5 by 4. At some high value of t, see, now at some high value of t, what is the high value of t? If suppose I am going to take t is equal to, let's say 10, then this will be very small and this answer will come out to be exactly 1. So here it is going to be 5 by 4, 1 into 1 times u of t, which is 5 by 4. So it will remain at 5 by 4. If I am going to expand this much section and have a look, it will look something like this. It is slowly going and it is saturating and coming like this. So that is what is the plot of this function. But don't worry, you don't have to do this in the examination. In the examination, mostly it will come up till this. Sometimes you may have to draw this, but it is not very, very important. What is important is that you should be able to get this function, which you can get it by Laplace inverse, doing the Laplace inverse. Now from here I want to tell you something. See, up till here it was some initial condition. From here onwards it is transient. That means it is changing. It is transient condition. And after it has reached a saturation, I will call that this is the final state. So here it was the initial state or the initial condition. And then you had the transient state where the value was changing. and here you have the final state where it has achieved what is going to be its final value. What you have got here is the equation for exactly the transient state as well as the final state. Now there is there is a small extension that may be asked. You may be asked, suppose you may be asked in the question, what is I of t at t is equal to 5 seconds? So what is the value of I of t at t is equal to 5 seconds? At that time, you have to find out the value of it by substituting at t is equal to 5. So you will get 5 by 4, 1 minus e raised to power minus 5 into 2, 10 u of t. You substitute the value of e raised to power minus 10 and then find out this value, you will get a value. And that value you will write it as the answer. If you substitute the values, you will get the value here as 1.241, and since this is current, I will write this as amperes. That is at 5 seconds, what is the value of the current flowing through the circuit, and it is changing, isn't it? It is changing, that's why it is called as a transient. So this is the case when we are having, a unit step, or not unit step, a step input. Let us also look for what will happen when it's a impulse one. So the second one is impulse. In the case of impulse, V of s is going to be equal to V of t. In the case of impulse, V of t is equal to delta t. Therefore, V of s is going to be equal to Laplace of that, which is 1. The same circuit we will have. I am not going to change the circuit here. It is the same circuit, but instead of V of s is going to be 5 by s, it is going to be 1. So, I will redraw the circuit and I will just write this as plus minus V of s is equal to 1. And then I am having the resistance which is 4 ohms, the inductor which is 2s ohms, and the current which is going to be Is. I am interested to find Is, therefore I will put I of s, I will have to do KVL. So using KVL, I will be able to write plus 1 minus 4 I of s minus 2s I of s is equal to 0, or I will get I of s is equal to 1 divided by 2s plus 4, which I can write it by dividing by 2. I will get 1 by 2 divided by s plus 4. See what I have done? I have kept the coefficient of s is equal to 1. Therefore, taking inverse Laplace transform, I will get I of t. You can very clearly see using inverse Laplace transform, you will get 1 by 2. What is the Laplace of 1? But Laplace inverse of 1 by s plus 4, it is going to be, the Laplace inverse is going to be, it's going to be e raised to power minus 4t u of t. So I will write e raised to power minus 4t u of t. So this is going to be the equation for the case when it is going to be an impulse input. The third case is going to be for the case of sinusoidal inputs. So what is the sinusoidal input? Sinusoidal input means I am talking about V of t is going to be equal to either sine omega t, where I will assume omega is equal to 5 for the time being. Okay, 5 radians per second. 5 radians per second. Always the unit of omega is radians per second. So it is, assume it is 5 radians per second. So I will take for one case where V of t is going to be equal to sine phi t, and for another case I will consider cos, that I will do next. Okay, so based on this, what will we have? We will have v of s is going to be equal to, we know that sine omega t is basically omega divided by s square plus omega square, which is going to be 25. So again I will draw the circuit. The circuit is plus minus v of s, and v of s is now going to be not 1, it is going to be 5 divided by s square plus 25, and then we are having a resistor which is 4 ohms followed by an inductor which is 2s ohms, and then we have it coming back, and now we will write what is the current I of s. Therefore, using KVL, I can write that, taking from front of the element, so this is plus minus, this is plus minus, this is plus minus, so it is going to be 5 divided by s square plus 2s, sorry, not 2s, 25, okay, 5 divided by s square plus 25 minus 4 I of s minus 2s I of s is equal to 0, from which I will get I of s is equal to 5 divided by s square plus 25 divided by 2s plus 4, from which I can, again to make the coefficient of s is equal to 1, I will divide it by 2, so 5 divided by 2 divided by s square plus 25 and s plus 2. This I can write it in partial fraction form as a divided by s plus 2, which is for the simple pole, and for this complex pole I will have to write plus bs plus c divided by s square plus 25, from which I can find out, using partial fraction technique we have already studied, I will find out a to be equal to s plus 2 multiplied with I of s, okay, at s is equal to minus 2, so that if I am going to do, I will get, so I will get 5 by 2 divided by s square plus 25 with s is equal to minus 2, which I will get it as 5 divided by 2 divided by s square is going to be 4 plus 25, which is going to be 29, and 2 times 29 is going to be 5 divided by 2 times 29 is going to be 58. So 5 divided by 58 is the value of A. Similarly, I can find out the value of B by using a cross multiplication. I can do cross multiplication. I can find out the value of B and C, and I can find out its values. This I will leave it for you as an assignment or as a worksheet to do today. Find the value of B and C and find out the value of I of t. So these three values you have to find out. Thank you.